Good morning. Hey, this is our lesson for Tuesday, October 17th. We've got just a little bit left of lesson 2.1 that I wanted to complete today. We're going to be in activity 3. And if you're gone today, we had a hand-on activity, and I'm going to try and explain to you what we did. So we continue to talk about what it means to be a soft solid rock, which is the mantle, and how is that different than the hard solid rock of Earth's outer core. So we used these two physical models to try to explain how the soft solid rock helps or aids in the movement of the plate boundaries, which is the hard solid rock. So we used silly putty and a plastic cube. And the kids took those out, and we talked about how the silly putty is a solid, and they're both solids because they both hold their shape. They've got their molecules that are super close together, so that's why they hold their shape. They don't take on the shape of the container they're in. If they're not in a container, they wouldn't go flat like a liquid would. And we talked about how this silly putty is malleable, so they were able to roll it in a ball, flatten it. They pulled it. It's also what's called ductile because you can pull it into a string. It's also like if you pulled it super fast, it would snap and break. And so then I said, okay, let's go ahead and do those things with the cube. And of course, we couldn't do it. You can't roll the cube into a ball. You can't make it, squish it flat or stretch it into a string. So we talked about, again, that word malleability, or the ability to change the shape of something. So the soft solid rock is different than the hard solid rock, just in the hardness, not the texture. They weren't soft and hard like the surface when you went to go to feel them. They're both smooth. That's the texture. So then I said, okay, how do you think that soft solid mantle allows the plates above it to move? And we talked about, I'm going to get out of this really fast. We talked, actually, here's what I did. I had the kids take their silly putty and kind of make it go flat and then roll the cube on top of the silly putty, and it just sort of slid on top of the silly putty. And so we were able to model how the plates move across the soft solid rock of the mantle. But I'm going to be honest with you. Now, this is above 7th grade standards, and we don't need to remember this. But it's not enough. I think it's not enough for us to just say that the mantle moves the plates. I want to show you how. So convection currents. Thinking back in when we talk about wind. Do you guys remember when you were talking about wind? Water or air that's heated rises, and then as it rises in the atmosphere, it's going to cool, especially over by water. It's going to cool and it's going to drop again. And then it goes over the land where it warms up, and it just kind of continues this cycle over and over again. I know you guys talked about that when you talked about weather. If you just think about warm air rising and cool air is going to fall, or it's going to go lower. If I have a cup of hot tea, where is that? I'm going to say hot tea, thermal energy. Let's see what comes up. We were talking about this in class, and it's a little bit more difficult to there we go. Okay, this is what I want right here. So your thermal radiation, if you just pour hot tea in a mug, immediately that mug is hot. But if you leave the mug over a course of a half an hour to an hour, it's not hot anymore. And the reason why is because the thermal energy leaves the cup. It goes from an area of high concentration to low concentration. So after a while, there's a loss of heat in the surface area of the cup because it's all been kind of radiated into the atmosphere, into the air around it, into the table, and then into the air around the table. So then that same idea, I want you to apply that to convection currents in the mantle. And I'm going to show you this. Let's see, I'm trying to find this one here. Does that one work? No, it doesn't. Hang on, I'm sorry. I found one that works really, really well. And it moves. Maybe it's this one. No, that's not it. And it was green. Sorry, this one right here. Okay. So the convection current, look at what's happening here. The green part right here is the crust. It's labeled the lithosphere because that's the very fancy geological term for the crust is the lithosphere. And then below that is the mantle. And below the mantle, you've got the outer core and the inner core. So, of course, the heat from the inner core radiates out. It goes to the outer core. The heat from that radiates out, and it warms up the mantle. So this is the soft, solid rock that's in the mantle. Notice the red arrows. When that soft, solid rock is warm, remember the mantle, this is where magma is. Okay, it's the soft, solid rock. That's magma. It is going to heat up when it's closest to the core, and it's going to rise. And as it rises, it starts to lose thermal energy. It cools, and it comes back down and then gets heated up. And it's this huge kind of conveyor belt of moving magma. Well, that magma, when it gets to the top of the mantle, it is the force that is pulling the crust. So if you look at the left convection cell, when those blue arrows get to the top of the mantle, they're at the bottom of the crust. They are grabbing the crust and pulling it to the left. And the convection cell on the right is grabbing it and pulling it to the right. So you would have opportunity for convergent and divergent plate boundaries due to the motion of the mantle. Again, this is above 7th grade, but it's important. I want you guys to know where all that motion comes from. At the very end of the day, if I ask you, how do you think the soft solid mantle allows the plates above it to move? It moves because it's soft solid rock. Okay, how do they move? They move because they're on top of the mantle. So here's our key concept number 5. The first part of that I highlighted in pink because that is our key concept number 4 from PB1. Earth's plates move. But then the key concept number 5 says they move on top of a soft, solid layer of rock called the mantle. Kids are going to be coming in here, so I'm just going to go through this real quick. Oh. Hang on. I am recording. Just a minute. So can you go outside and just tell everybody I'm recording? Sorry about that. Don't shut it. Just stay right there. All right. I'm going to skip the warm-up. This is your activity. I want you to read and annotate this article. You're going to read about convergent plate boundaries and divergent plate boundaries. In the in Schoology today, you see that PDF, Listening to Earth's article. You may use a colored pen or marker in your good notes to underline, draw a box around, make a note. I do not want you to just highlight the passages. Remember to annotate. Annotation is the skill that I'm using to assess you today. So if you turn in something that is only highlighted and that's it, you're getting a 0. That is not an annotation. So make sure that you do that. When you're finished, go ahead and submit it to Schoology, and I hope to see you tomorrow.